Welcome back to Geeks for Geeks. So today we are going to solve a problem which is named as rooftop. Let's quickly have a look on the problem statement. So the problem statement is you are given the heights of consecutive buildings. You can move from the roof of a building to the roof of the next adjacent building. You need to find the maximum number of consecutive steps you can put forward such that you can gain an increase in the altitude with each step. Okay, so this is the problem statement, and let's look the example. So how are the example given to us? Okay, so we are given an array whose elements are 1, 2, 2, 3 and 2. So these are the heights of my buildings, and if I try to make or like show them, so it will be like the one building, the first building will be having a size or height 2, and then a building of height 2. First building was having height 1, and second building is having height 2, and again second building is having height 2. Then again a building with height 3, and then again a building with height 2. So if I try to visualize them as a building, so they will be looking like this, and it is given in the problem that you need to find the maximum number of consecutive steps you can put forward such that you gain an increase in altitude with each step. So what does this line says that, so if I try to move from one building to another building, then the altitude should be increased. So for example, if I am at building 1, then I can jump or move to building 2, right? Because it has an increase in the altitude, because the building 1 has height 1 and building 2 has height 2. So there is an increase in the altitude. But we can see that after the building 2, I cannot jump to the next building because it does not have the altitude increase. So I cannot move from second to 2, so I will not count in my I will not count this third building into my steps. So now what can I do? From building 2, I can move to building 3, right? Because it has an increase in the altitude. So there are two possibilities in this. So one possibility is that I can move from building 1 to building 2, and how many consecutive buildings are there? So there are only two consecutive buildings. And what is the second possibility? So the second possibility is that I can move from 2 to 3, and what is the height or the consecutive elements building? So it is also 2 here. So from building 1, I can move to or jump to building 2, and I will have an increase in the altitude. And similarly, from building building 3 with height 2, I can move to building 4 with height 3, and it will also have an increase in the altitude. And similarly, let's see the example number 2. So what does example number 2 state? So there are four buildings with 1, 2, 3 and 4. So let's try to draw them or visualize them as a building. It is having 1 and 2 and 3 and 4. If I try to draw example number 2 as the building, so they will be looking like this. And let's see how many number of steps I can take consecutively, so that I can move from building to another building. So let's say we are at building number 1. So can I jump to building number 2? Yes, because it has an increase in the altitude, because building 1 has height 1, and the building in which I am going to jump has a height 2 which is greater than 1. So yes, I can jump from 1 to 2. Then I can say that the maximum consecutive buildings I can jump till this index is 1. And now let's try to see if we can jump from building 2 to building 3. So we can see that building 3 has an altitude of 3, and the current building has an altitude of 2. So we are getting a building which has an increased altitude, right? So that's why I can also jump from building 2 to building 3. Okay, now let's try to see if I can jump from building 3 to building 2. How can I see? I will try to find out what are the heights of these buildings. So we can see that building 4 has height of 4, and the building in which I am on current is having height 3. So yeah, I can move from building 3 to building 4, right? So how many consecutive steps I have taken? So this is the first step, this is the second step, and this is the third step, right? So I can say that number of consecutive steps I have taken is 3, which is maximum for this example, and that's why our output is also 3. So we can see in the explanation part also 1 to 2, 2 to 3 and 3 to 4. 1 to 2, 2 to 3 and 3 to 4 is the jump of length 3 to have a maximum number of buildings with increased heights. So maximum steps with an increasing altitude becomes 3. Right. So I hope the problem statement is clear to you. And now let's move to the solution part. Okay, so the solution is pretty simple. What we can do is I can keep the track of the number of consecutive buildings that I have covered till that index, and if the next building in which I am going to jump is having lower altitude or the equal altitude than my current building, then I can say that hey, I cannot move consecutively from this building. So that's why what we can do, we can just simply take a counter variable. So we are taking a counter variable. What does this counter variable will be storing? So it will be storing the number of consecutive buildings that I have converted that index. And now we also have one answer variable. So what this ANS will be storing? So it will be storing the answer for this particular example that we have taken. So let's try to move from building 1 to building 2, right? So we can see that I can move from building 1 to building 2. So that's why I will increase my counter variable by 1, because it is keeping the track of the buildings that I have taken consecutively till that index. So right now I am at index number 1. This is index number 0. This is 1. This is 2. This is 3. And this is 4, right? So at index number 1, how many consecutive buildings I have taken? So I have taken 2 consecutive buildings, but what is the number of steps? Because we have to count the number of steps, right? So I have taken 1 step from building 1 to building 2. So that's why I will increase my counter by 1, that I have taken 1 step. Now at index 1, can I jump to a building with index 2? We can see that yes, because 3 is greater than 2. That means that the next building has an higher altitude than the current one. So I will again increase my counter by 1, that I have taken 3 steps till this index, and I am moving consecutively, or I am jumping from buildings consecutively and with higher altitude, right? So I have jumped from 2 to 3. Now we can see that from 3 to 1, can I jump from in building 3 to building with height 1? No, right? Because it is given in the question that I can only jump to next building if it is only having a higher altitude, right? So we can see that we cannot consider this building right now. So I will start my new number of steps, because at building 3 I can only take 2 consecutive steps to move from building 1 to building 3, right? Now from building at index 3, I will again reset my counter variable, because from this current building I am restarting the consecutive steps. Okay, so again reset the value of counter. Also I will store the maximum value of my counter variable in the answer variable. So because I have to find out what is the maximum number of steps, so at every point I can take maximum of counter variable, and that maximum value will be my answer, because I have to count the maximum number of steps that I can take, right? So at before the index 3, at index 2, my answer value will be increased or replaced by 2, because this is the maximum number of steps that I can take till index 2. Now at index 3, I will again reset the value of counter by 1, counter by 0. Now again check if I can move from building 3 to building 4. So yes, because building 3 has height 1 and building 4 has height 2. It has an increased altitude, so I can move from building 3 to building 4. Then I will again increase the counter by 1, that I have taken 1 step, right? Now and answer will be taking the maximum value of the counter variable. Now after index 4, there is no building next to the index 4, so I can finish that yes, this 2 is the answer for this particular example, right? So let's try to see how we can implement this. We have our max step function name, and we are taking, or we are being passed one array of vector, and ARR named array, and at line 14 I am making one count equals to 0 and answer equals to 0. That we have seen that why we are making counter variable and answer variable. Right now we are starting from building number 1, that is the first index. So we are checking if the previous building is greater than the current building. So if it is greater, it means that I cannot jump from the previous building to the current building. And if the previous building has height smaller than the current building, then only I can jump from my previous building to the current building, right? So we can see that if array of I minus 1, that is the previous building height, and if it is lesser than the array of I, which is the current building height, right? So then only I can take one step. So that's why I am doing count plus plus, because I have taken a step from moving array of I minus 1 building to array of I building. Okay, so that's why I am doing count plus plus. Else, if the previous building has height equals to or lesser than the current building, then in that case I cannot jump from previous building to the current building. So that's why I am resetting the value of my counter variable as count equals to 0. That means that I have not encountered any number of steps or any number of buildings. So that's why count equals to 0. And at line 21 I have to find out, you need to find out the maximum number of consecutive steps that you can take forward. So it means that I have to take the maximum value of my counter variable. So at each iteration I am taking the maximum value of my count. Now in the end, at line 23 I am just returning the value of my answer variable, and which will be storing the answer for this particular question. So I hope this problem statement and problem solution is clear to you. Now let's talk about the time complexity. As we can see that we are iterating on our array only one time, and the size can be n. So the time complexity would be big O of n. And talking about the space complexity, the space complexity would be constant because we are not using any extra space. Thank you guys for watching this video. If you found this video helpful, then please like and subscribe to the channel. Thanks.